So let's start with y equals square root of x, and we're going to go from 0 to 4. So the square root of 0 is 0, and the square root of 4, so that's 2, 1, 3, 1, 2, so that's 2, and 1. Okay, so we've got this, right? Square root of x. Should actually be a little different-ish. And let's say we take a dx, right? So we take a little width here, right? So if we're doing like the area under a curve, then we use that, right? We sum up an infinite number of infinitely small little rectangles, and that gives us an area. So that would be, if we do something like 0 to 4, the integral of root x dx, right? So this is the height, and this is the width of the rectangle, and we sum up infinitely many, infinitely small widths, and that gives us the area. So what if we take this curve and we rotate it around the x-axis? Right? Then we're going to get a shape, right? We're going to get a solid shape if we say that this disk is solid. Okay, and now here comes the drawing part, which is going to be probably pretty bad. Right, so this, every point on this is going to describe a circle, right, of radius, which is the height of the thing. And so then this solid here, right, is going to rotate through. Right, so we'll get kind of some solid-ish shape. It's like, imagine, it's like a coin. I told you, drawing sucks. So basically, what you get like a coin, the edge of a coin, right? And so we have a small, with the width of the coin being dx, and the radius of the coin being the height of the function, right, or square root x, right? F of x or square root x. Let's go look at this in for real. All right, here, this little animation here will be kind of handy. So they're going to draw y equals the square root of x. They're going a little beyond that. And what they're doing actually is an area between the square root of x and 1/10 x. So it's slightly different. We have a solid thing. They're going to have a little shape out of the middle of it. And they take that solid, and then showing it side, and they rotate it around, right? Oh my goodness. So ours is totally solid all the way through, and theirs they have that little piece of, right? And then there's your disc. So in this case, that's actually called a washer. You've all seen washers, right? You put on a bolt and then that in the washer, right? It's got a width and so on, right? So, anyway, that's.
Say it again. I don't understand.
That's something you can see. Well, I'll show you a different one.
You don't get the solution.
You draw it.
Yeah, that's arts class. No.
Come on. Cam. That's right. Okay, here. This. So we take, see, those are our discs. So that's how you take these whole pile of discs, right? And if you take more of them, then this gets a little bit smoother, right? And this one is actually what? It's like y equals x squared or something like that. Are we there? Oh, right, I know. So here, let's go here. We'll put in square root of x. Square root of x. And we're going to plot that. So here's the plot of y equals the square root of x, and it's going from 0 to 4 as well, right? And what I can do is rotate that around. That happens pretty quick. And if I grab this, then we can look inside and see, right? So that's the shape you get.
Wow. Wow.
Okay.
You're gonna miss out.
So, and that's looking. Remember, ours is a solid, right? It's a solid. So, so just imagine this is solid inside. It's all made out of chocolate or something like that, right? And that's the shape it has. And,
Live in there.
we can look at a bit of a beehive there or something. Right? And again, that goes back to what? We take the curve y equals root x, we rotate it around, okay, and that's what we get. Okay, so there, you've seen the for real thing. So, okay, good. You've seen the views. So if we imagine the disk, right? So we've got this solid disk, and the radius is the square root of x, right? From here to here, right? Because that's y equals root x. That's the radius. The width down here is dx. The area, it's a circle, so the area is equal to pi r squared, right? Which is pi times the square root of x, quantity squared, which is pi times x. So the area of the face of this disk, right, the coin, right, reaches in pocket, pulls out coin, right? So there's the disk. This is the face that we're looking at here, right? Sideways, we're kind of looking at the face of the disk. So its area is pi r squared. The radius is the square root of x, because that's our function. Okay, so that's the area. The volume is equal to the area times the height, right? The height of the coin, which is dx, right? Or its width. So it's the area of the circle times its height. It's a small cylinder, right? So it's the area of the circle times its height. So the volume. So the volume is pi x dx, right? Because that's the area, it's pi x. And that's the volume of one disk, right? That's one disk. So the overall volume is the limit as n approaches infinity of the sum of I equals 1 to n of the area as a function of the x value, x sub I, right? So if you remember back to Riemann sum, that could be the left side, the right side, or the center of that, which is really just equal to the definite integral from a to b of a of x dx. Okay, so our volume is, where shall we get the string missing? Okay, so our volume is the definite integral from 0 to 4 of pi x dx, which is equal, so pi is a constant, so pi from 0 to 4 of x dx. Okay, what's the integral of x? Right, x squared over 2. I think I heard myself say. 0 to 4. Okay, so we've got 4 squared over 2 minus 0 squared over 2. All right, so 16 over 2, which is 8, and this is just 0, so it's just 8 pi. Okay, so our volume is 8 pi. And I think one of these guys actually showed the volume. I'm gonna. So our calculated volume was 8 pi, and 8 pi is 25.13, which comes out here. There's the true volume, 25.13. Okay. Where do we go from here? Well, let's generalize this, right? That was a specific function. That was the function y equals root x. So in general, the area of a disk is pi r squared, but the radius is simply the height, right, or the function. It's the y value, which is f of x, right? The radius is f of x. So A area is pi times f of x squared. And so the volume, the formula for volume given on your formula sheet is pi, definite integral from A to B of f of x squared dx. Okay, and that's on the bottom of your formula sheet. Volume of a solid of revolution. Okay, now maybe, all right, let's do one where, so find the volume of the solid object. When the region Okay, so we need to, I think it helps to visualize what we're actually looking at here, right? So let's plot. So we've got y equals x. Got y equals x squared. Where do they meet? 1, 1. Right? I mean, you can work that out, right? So, okay. X squared is equal to x, which means what? X squared minus x is equal to 0, x minus. So x equals 0, and x equals 1, right? So it starts at 0, 0, and it goes to 1, 1. So we've got that solid. If we take a disk here, this is going to be solid material, and this is going to be a hole, right? I mean, there's nothing, that's hollow, right? Because there's nothing down. We've got this face here, so what we're rotating is this face, right? This red part. That's what's going to rotate, and we'll be left with kind of an inner shaped hole, right? Kind of this shape. So what will that shape look like? God only knows, because I can't draw it, but now let's see. So, okay, so you're going to have kind of a circle out here. This part here is going to sort of replicate down here, right? Like that. So the inside, the whole shape is like kind of like a Hershey's Kiss or something like that, right? Or a Sorry piece without the knob on, you know, and Sorry the game, or, you know, some kind of shape like that. And then this part here, down here, right? That's solid again. Okay, so you've got that solid rotation, and then you've got that hole in the middle. So if we think about it, we could say, well, I could work out the volume of just the line y equals x, right? What would y equals x? So let's just say we didn't have between here and here. We're just doing y equals x and taking that. What shape would we get? You get a cone, right? You're just taking a straight line, rotating around the x-axis. It's going to sweep out a cone, right? So we'd have a solid cone, and this would be its. Let's see, what's oh, that's, yeah, x squared, right? So pi f of x, right, which is y equals x squared, and from that we would subtract the volume of the hollow part, right, which is that sort of Hershey's Kiss shaped thing, right, which is pi times x squared squared dx. right? So if we work this out, we get pi 0 to 1. This is x squared dx minus pi 0 to 1 x to the 4th dx. So that's equal to, what's the integral of x squared?
X to 3.
X to the 3 over 3, right? This is the trivial one. Okay, so we've got pi times x cubed over 3 from 0 to 1 minus pi x to the 4th integral x to the 5 over 5 0 to 1. Okay, so we can work this out. It's going to be pi. So we've got 1 cubed over 1 cubed over 3 minus 0 cubed over 3 minus pi. We've got 1 to the 5th over 5 minus 0 to the 5th over 5. Right, so what do we got? Pi over 3 minus pi over 5. Right, that's just 1/3. That's nothing. That's just 1/5. That's nothing. Which is what? 5 pi minus 3 pi over 15, or 2 pi over 15. Okay. So we could do Oh, hang on, no. That's what we did do. Yeah, you could. So we could say, look, what's the area that we're interested in sweeping out? It's the whole disk. Okay. That's the WHOLE disk. It's the whole disk minus the hole in the disk, right? So it's the outer radius minus the inner radius, right? That's going to give us the solid piece. So this is the area, and that's what we're going to rotate, right? So instead, we just calculate the area, which is pi x squared minus x to the 4th. And so the volume is the integral from 0 to 1 of the area, right? The integral of the area, which is, let's extend that a swoop. Okay, so here's our expression for area, right? Pi times the outer radius minus the inner radius, so it's pi. We get x squared minus x to the 4th. Okay, so we're just doing that one, or we get the same thing here, right? But we don't have to now work out this, 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 and this, right? So it's just pi integral of x cubed, or sorry, x squared is x cubed over 3 minus x to the 5th over 5 from 1 to 0. Okay, so the 1s gives you 1/3 minus 1/5. The 0s gives you 0 minus 0. I'm not writing them out. Okay, I mean you could if you wanted, but they're just zeros. And that's equal to 2 pi over 15. Okay. Surprisingly, yeah. I mean, you get the same. Area. So if you're doing a disk, well, this way you don't have to do this volume, sort of the outer volume minus the inner volume. You're just saying, hey, I know that I'm just sweeping out this particular area, so let's just get a simpler expression for area. So you're saving a little bit because you're going straight to 1/3 minus 1/5.
Just whether if you combine the areas.
It's the difference between them. So in the disk method, area is equal to pi times the radius squared And in the washer method, area is pi times the outer radius squared minus, I guess it's pi times minus the inner radius squared.
You should do the circle around.
Okay. So, is it a huge savings? No, but it's just a little. It's a quicker way to get there. Okay, a couple more examples. So we'll do one with a trig function, we'll do an exponential function, and we'll find the volume of a sphere.
Wait,
What?
we just
Can you
want
do
to
that?
Oh, got it. Scroll down.
Square root of sine x from 0 to pi. All right, got a formula. All right, volume is equal to pi, the integral, 0 to pi, the square of this, which would be sine x, dx. Okay, so that's just formula off the formula sheet.
CTU.
I don't know. Yeah, that's the CTU ringtone. So what do we have? We've got pi. What's the integral of sine x? Minus cos x. Okay, evaluated from 0 to pi. So it'll be pi minus cos pi plus cos 0. Right, minus negative cos 0, so plus cos 0. What is the negative of the cosine of pi? What's cosine of pi? Negative 1. Negative that, 1. What's cosine of 0? 1. What's this equal to? 2 pi. Didn't want to have it on that. So if we plot the square root of the sine of x and then rotate it, we get a true volume of 6.28. Okay, what if?
What?
What if we do y equals e to the x from 0 to the natural log of 2? Formula? Sorry, formula is volume is equal to pi between 0 and ln 2 of e to the 2x. Remember, it's this thing squared, right? E to the x squared is e to the 2x. Power to power, multiply your exponents, dx. What's that integral? E to the x over 2, right? Or 1/2 e to the 2x?
Yeah.
You're doing a u substitution in your head, right? I mean, because we could let u equal 2x and blah, 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 right? But with these guys, you can just sort of say, hey, chain rule, so I'm going to get a 2x times e to the 2x, and I want an e to the 2x, I need half of that. Right, from 0 to the natural log of 2. So that's pi 1/2 e to the 2 ln 2 minus 1/2 e to the 0 So what's e to the 2 ln 2? What's e to the ln 2? 2. Squared is 4. So let's call that 4 over 2 because it's a half of 4. Minus a half of, what's e to the 0? 1. So minus a half. So 3/2 pi, 3 pi over 2. I don't know if we can do that on that other thing. Let's see if we can. Let's try. So here's e to the x from 0 to the natural log of 2. That's the plot. And there's the rotation, right? I mean, well, if you want to look inside, take a look inside. Look inside.
We calculated
The other one. It's kind of a frustrating. Okay.
Are there units on this?
No units.
Even though we're finding area?
Oh, okay, so it'd be cubic units, right? Units cubed or cubic units. So 2 pi, the other one was 2 pi cubic units, yeah, 3 pi over 2 cubic units. Find the volume of the sphere. When rotated about the x-axis. So, what's this thing? What's x squared plus y squared equals 4? It's a circle, right?
Yeah.
You guys, did you guys do that? Have you done that before? Because yeah, we don't do conics anymore. So
Is that an x squared?
yeah, it's x squared plus y squared equals 4. It is. I think you might have seen it in 20.
I think you should
No?
once.
Damn, it's like the distance formula, right? Well, let's wait until the final course in high school and we'll talk about the distance formula. It's like a pretty. But that's a circle. Okay, circle with radius 2. Okay, so x squared plus y squared equals 4. So we're taking that circle and we're going to rotate it. What shape are we going to get? Right, you're going to get a sphere, right? So we get a sphere. So volume is equal to 2 pi. Okay, now I'm going to say 2 because what we're going to do is we're just going to take this chunk here, right? We're going to go from 0 to 2, take this piece. Now if we do that, we'll get a hemisphere, right? So we'll double it to get the volume of a sphere. So we need to go from 0 to 2. So the volume is 2 times pi, 0 to 2. And we need the y value. So what's y equal to? Well, y squared would be 4 minus x squared. So y is the square root of 4 minus x squared, right? So we're taking the square root of 4 minus x squared and squaring that. Okay? So we have to solve for y. Right? And I think in the book it asks you to do an ellipse. And so again, you'll have to do sort of the same thing, right? You'll have to take this ellipse and without knowing that it's really an ellipse because you never studied conics because they took that out. Yep. Yeah, but what's the y value here? This is 2, but what's this? We need the height. The height is y. What's y? We got to solve this for y, right? So we take x squared plus y squared equals 4, solve for y, and then solve for y, right? Take square root. Okay, and we're squaring that, so the volume is 2 pi. Remember 2 because we're really just going from here to here, so we're doing a hemisphere, we're doing half of it, so we need 2 of them. 0 to 2, and this will just be 4 minus x squared dx, which luckily enough is pretty easy to, integrate, right? So 2 pi. Well, we don't need the integral anymore, we'll just do the integral. 4? No, we're not counting. 4x minus, I'll say it louder, what's next? X cubed over 3?
3x.
Okay, don't say it that loud. From 0 to 2, Okay, now, when we go to put the zeros in, they're just zeros, right? So I'm not going to put the 0, I'm just going to go 2 pi 4 times 2 minus 2 cubed over 3. Okay, the zeros minus 0 minus 0, or minus 0 plus 0, if you like, right, because of the zeros. Now, you won't always, maybe we're working out a sphere or something like from 1 to 2, and we're just taking that piece. So don't always just sort of say, oh, I don't need to worry about this. If it's 0, then you're not worried. Okay, what do we got? 8 minus 8 thirds, which will be 24 minus 8 is 16 thirds, which will be 32 pi over 3. Okay, now I guess we can find out if we can do it. What's the formula for the volume of a sphere? Four thirds pi r cubed, right? What's the radius in this case? You know, the formula yields the same result as if we found the volume by rotating the circle around and getting the sphere. So here we went from -2 to 2. You could do that here, right? But then you're going to let yourself in for a lot more calculations because you don't just get to put a 0 there. So it's easier to say, hey, if I just double, if I go from 0 to 2 and double it, I'll get my answer, which is the same answer I would get if I didn't double it, but I went from -2 to 2.
Wouldn't you have to explain it from?
You don't have to explain it. Well, I explain this, why I'm doubling. Yeah, I suppose you should put a little explanation in. Well, which I did, right? I mean, that's up here. So we're just doing this.
Why would we need to explain it? I think you know. It's a calculus class.
Yeah.
If we get the right answer.
Because I'm kind of dumb, so I need.
So like, so if we didn't explain it, we got the right answer. Do you just that's
It's the end of the year. We might be generous and just sort of say.
Yeah.
Yeah.
Just like try to pull the wool over my eyes.